Hello, everyone. Welcome to this week's episode of ClueCon Weekly, sponsored by SignalWire. This week, joining us is Nickolay Shmyrev from the Vosk project and open source speech recognition expert. And I have a lot of questions for you because it's a field that's always intrigued me. So thank you for joining us today, Nickolay.
Thank you for inviting me, Luca, and hi everyone. Yeah,
Would you
it's
like
my
to give us a quick introduction about yourself, what you do, what your background is?
yeah, sure. We are working on speech technology for many years. We worked with the Sphinx before, with many TTS packages like Festival. We worked with different toolkits, and these days we have this toolkit called Vosk. It's an open source speech recognition toolkit with many languages supported, with integration with for telephony and integration in mobile apps, which is used here and there. So that's what we are doing all the day.
Oh, wow.
Uh,
Okay,
mm,
so that I mean, again, that's super interesting to me because I've been trying to use open source speech recognition on and off for a while, never really got it quite right, etc. It is very complicated. So, first of all, what are the challenges in general of running speech recognition? Why is it probably the only thing that open source doesn't have quite right?
mm, well, for some people it may be a challenging thing, but for us it's a daily routine. So
Oh, nice.
yeah, you can just run it. Of course, you need to adjust your expectations because it's not always perfect, but still, even at the current level of accuracy, it's still useful and can be used in many different kind of areas, from monitoring to interactive voice response from different chatbots and agents. So definitely there is something useful you can make with the speech recognition these days.
Then I need to go try again, which is something I will certainly do in the next few days. And so you were a speaker on ClueCon in February, I think, last February when we had the ClueCon online version. And I think you have some newer stuff that has been going on since. So if you'd like to start from there, maybe if you have any slides to share, go ahead.
Yeah, yeah. I think I've been a speaker at ClueCon in 2009, and it was a great experience those days, and I loved Chicago. But
Yeah, well, come back
yeah,
this year if it happens to be in person.
yeah, but yeah, since then there are many updates. Let me share with you my presentation and just go through some items we have in Vosk recently, which I want to share with you. So yeah, I think it's good.
Good, yeah,
Oh,
works
so,
perfectly.
yeah. So to update what's going on in Vosk, we've got several cool features which I'd like to talk about today. There were some standard things which might be interesting for the telephony guys, like integration with the switch. We done this some time ago, and I have reports some people are using it successfully. Then we've got the implementation of the UniMRCP plugin, which is kind of also an important thing because you can replace the WAS infrastructure with the uh, standard infrastructure you might be using with some other providers. We also work all the days to increase the amount of languages we support, and now we support more than 20 languages, though most of them are not really for telephony, but still, we just added Japanese, for example. So if you are interested in accurate Japanese speech recognition, you can try Vosk. We also have many different programming languages supported, because I know some people are kind of the Python is our main language. It's kind of a main language of the artificial intelligence these days. But I know many people are still, fans of JavaScripts and Go and things like that. So it might be interesting for them too. And a few important updates I want to share today. First of all, it's an updated documentation and updated training process for adjusting the vocabulary of speech recognition, something that our users, always require to provide. Then the biggest thing that we recently implemented is the GPU decoding, which is really exciting way to
Wow, yeah.
handle a lot of speech channels on a single server. Um, so to start with the updates, one important update we had in September is the new recognition model. We actually improved the models, periodically, maybe once in 3, 6 months. But this update is kind of interesting because it for a long time we didn't have a good call center model for the telephony, and now
Hmm.
we have a really really good model which you can use in a Vosk. um, you can see the numbers here. Those are percent of mistakes. The first column now is our previous model. Then there you can see the new model, and then there are two models which are kind of interesting to try. Two, one is Nemo from Nvidia, and another Wave to Vec from the Facebook. I provided here some accuracies for the different test set. You see it's still kind of high word error rate, but there are still good improvements, and the model is more or less competitive. So you can actually get a very good accuracy.
Yeah, it looks like it's actually better than the Facebook model.
Yeah, sometimes it's better than the Facebook model. Sometimes it's worse. It's kind of, it's a complex thing because the people are kind of training the model to fit one set, and the reality is that you have the problems with another set. So there are no such thing as a universal thing. Some models are better on one task. Some models are better on another task. I know, for example, if you have a call center with non-native agents, for example, somewhere from Peru or from Latin America. They have an accent, and this accent affects the speech recognition accuracy. And I believe this call center one is accented call center speech. So you can see that we are getting more or less the same as Facebook and probably better. But yeah, it all depends on the case.
Hmm.
And another point I wanted, yeah, but Luca, please ask
So
if
what
you
are the
can.
different? Yeah, I'm curious about something. What are the different models in short? Like those call center one, two, and three are those? I suppose those are call center recordings you use as a sample, and then the podcast is like a better quality conversation, something like that.
Yeah, yeah, and that's also another important thing I wanted to mention. So the progress in speech recognition these days, it led to a point where you do not need to have a specialized model for the different sampling rate. And if you remember old times, the big difference was that there was a call center model, like Google, they have the call center model. And then there is a wideband model for the wideband speech recognition. And those models are not interchangeable. So if you have the call center model, it recognizes well call center, but it's not doing really good on the wideband. And if you have the wideband model, it's doing well on the wideband, but it doesn't do well on the call center. And what happens these days, you have all those web conferences and mixed speech, and people can call from different, legs. They can use the WebRTC, others use the telephony. And these days, it's pretty common to have mixed band speech.
Hmm.
And that's the important innovation of the recent models. And you can see that our recent model and the Nemo and Facebook model, they have the mixed band training, which means they support both sampling rate out of box.
Hmm.
And that's a kind of interesting feature, and it really brings the accuracy. But also, there are interesting changes that are required in the free switch itself. For example, when you send the data through the UMRCP, you cannot send wideband, right?
Hmm.
So it's an interesting opportunity here to improve the accuracy and probably implement some new cool things in the free switch itself or in the integration of the free switch with the engine. Yeah, so that's something I wanted to share. And if someone is interested in kind of trying this thing and mix it setup, and trying how it works, or maybe setting up some special. I'm sure there will be some bugs to
Hmm.
fix, but some new features to implement. But potentially it can bring really good results for modern conversation, which happens both in the wideband and the narrowband.
Hmm. I see. So the main thing here is that, I've never had an application where I had mixed band audio really, because it really comes from one source usually. So I'm curious, what's an example of having some 8 and some 16 kilohertz?
Yeah, like if you have the web conference, but someone
Mhm.
calls from the phone.
I see. All right. Yeah. So the sampling rate is actually a format issue, but it's also a quality issue.
Yeah,
It's not just the
exactly.
fact that it is in 16 bits, as in maybe that's sorry, 16 kilohertz. That's super interesting. Yeah, that's something I never thought about. Still, the percentages there look quite good. I wonder what that call center one recording is, but has to be terrible. So,
Yeah, those are just sample data sets from the from the projects we had. Call center one, I believe, is more like non-native agent speech, uh, probably from Peru or something. Call center two and call center three are US based agents. The
what's
numbers might be different, but the thing is that the main factor is inaccuracy is not the engine anymore. It's more like the quality of the recording. Things like
hmm?
frame drop, things like frame drop or compression, they affect the accuracy of recognition the most.
So
So
if you have good pipelines, that will affect recognition even more than the quality of the model.
exactly. That's the main factor. Like you see on the podcast, the recognition accuracy is much better. So if you can provide good quality of the recording, then you can get much better uh, speech recognition
Oh, that's
accuracy.
that's very interesting and something I didn't know. It's really cool. So, what else?
Okay, let's go to the next point. So the next point is the language adaptation. One issue with the Vosk model is that they have the fixed vocabulary, so they cannot recognize new words.
Hmm.
You have to specifically inject those new words and their kind of probabilities into the model so they are recognized correctly. So it's usually a problem for any kind of enterprise deployment when you need to recognize serious terms or when you need to recognize some specific names and things like that. And people are always asking, like, how to do I inject the new words? How do I improve the accuracy? And
I actually
actually,
know a company that uses made up words to do dictation, so that when they dictate something and they say a word like la la la, it
mhm.
inserts a comma and goes on a new line or something like that. So that makes it easier for their captioning to work, because they don't have to type anything. They just say la 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 and it goes to their line. So that's very important for sure.
Right. And actually, it's a big factor of the accuracy because, and it's not just about knowing the words, it's also about knowing the context around them. So you need to understand in which context this word appear. Because you, for example, might have the speech recognition. It depends on the context a lot. So if you know the word like I went, you kind of imagine the continuation. I went to school or I went to
Look,
office.
yeah.
Yeah, instead of, so you need to understand this probability even for the new words. If you know the word la la la, you need to understand in which context that's going to be. So these days, there are technology that can recognize all the words, like this Nemo technology. It can recognize all the words, but it still need to understand the context.
Hmm.
And what we do, and that was the frequent request, we provide the scripts, we provide the capabilities for the users to compile their vocabulary and their phrases into the model. So the model should learn those words, should learn those terminology, and can recognize the terminology much better than before. Um, Usually, we had this kind of process as kind of enterprise product before, but now we release this to the public, so you can do that yourself. And that's one of the advantages, and actually thing that brings the accuracy of recognition to levels much better than standard setup. Other providers like Google, for example, Google also know this problem. They account for this problem slightly differently. They have the word hints. You can add
Yeah.
up to 5,000 words. But because you do not specify the context, you just specify the word. You cannot really uh, fully use this additional information. Some companies like Microsoft, I believe, allow you to upload the text in a similar way like we are doing. But what we suggest is just to do this all offline, which is kind of a nice thing to do. And that's a new thing which appeared just this summer.
That's super interesting. Cool. Yeah.
Okay, the next thing I wanted to mention is NBEST speech recognition variants. We introduced this in the telephony recently with this NL, SML output from the UniMRCP, and we have this in JSON. And just wanted to mention that because I know many people who are building IVR system with the speech recognition, they still rely on one best output. And this is not always reasonable. Sometimes the recognizer can actually return you much more than that. It can return you the variance of speech recognition. And based on your logic, based on your current moment, you can use these variants to guess the proper answer and handle the speech request much better. I know that there are, so that's a pretty old thing in the speech recognition that you can get the speech recognition variants and handle on them. But surprisingly, I know many companies who are building chatbots with just one best. And just wanted to mention this as an additional practice you can try and you can employ. Okay, yeah, so that's available on the server. That's available in the UniMRCP if you're going to use UniMRCP. There is no confidence for NBEST in Vosk yet, but that's something we are working on, so maybe sometime later.
Cool.
Okay, and the biggest thing I want to share is about GPU decoding. So when you have a call center, when you have many calls, the first question you ask, how many servers do I need to handle the speech recognition?
For sure. Yeah.
And of course, the speech recognition is pretty resource heavy process. It requires much more compute than simple codecs. So it's not like your single Raspberry Pi free switch can handle tens of hundreds of conversation anymore, no matter how free switch is optimized. So people are asking, how many servers do I need to handle? So because we are running online speech recognition, we count in streams, in parallel streams. And the situation is like this. So on the CPU server, you can handle about 3 streams per core. That can be optimized if you really want. We can reduce it to 5 to maybe 6 streams per core, but the range is about that. And if you have the, say, 20 streams, you can handle them on a single i7 server with 8 cores. Well, pretty standard adult hardware. But if you want more than that, you need to increase the amount of cores. And the situation here is that there is a specific on speech recognition because it's as any AI application, it's a memory heavy
Intensive. Yeah.
process. When you increase the amount of cores, there is a factor of memory bandwidth come to play. So when you have 48 cores, you still can process many streams, up to 8 streams, but you see you have much less streams per core than for the small server.
All right. Yeah. Because of memory.
Yeah, that's why I kind of always suggest people to have many small servers instead of one big.
So you need 10 gigabytes of memory per thread?
No, that's total. That's total.
So
Total 10.
one box with 10 gigs of memory and 8 cores can do 20 streams.
Yes.
Well,
for
that's
example.
I mean, that's some part you can buy VPSs or virtual machines from Amazon, DigitalOcean, and Google who are in that ballpark without spending too much money. So
Yeah. So,
looks
for
good to me.
example, for AWS, for 20 streams, you need this C5.4
Hmm.
X
Okay.
large AWS server. There is also an interesting thing here. I know some people are running this speech recognition on ARM servers on Amazon. They're kind of cheaper, and if someone wants to collaborate on this and try, that would be interesting thing to try. But the reality is like that. Yeah. So you need like one C5.4 X large to run 20 streams. And of
Oh,
course,
nice.
that's not enough for the big call centers, but that's probably okay for the small enterprise. So yeah, that's why the GPU comes in, and that's why that there is a great and coolest technology
Wow.
from Nvidia, which enables much bigger processing bandwidth. So recently we implemented the Nvidia technology, and there is really cool technology which runs all the speech recognition on the GPU. And because GPU is much more memory bandwidth friendly and much more compute kind of powerful, you can process much more streams. For example, if you have a GTX 1080 card, this is a pretty old one, you can process up to 100 streams in parallel, which is kind of much better than before. And with the recent generation, you can process up to 300 streams. And that's for online processing when you get the real-time responses. If you don't want the real-time responses, actually the throughput is much higher than that, and you can process up to 1,000 streams in parallel, not the streams in parallel, but up to 1,000 hours of data in 1 hour. So much more if you want to run the analytics. The API of this implementation is fully compatible with the CPU server. So you just start this Docker container in NVIDIA. You need to install CUDA 11.4. You start this Docker container, and you can just use standard FreeSwitch integration infrastructure like FreeSwitch plugin or UniMRCP. UniMRCP is not yet ready, but probably going to be ready soon. So yeah, you can use the Vosk FreeSwitch plugin, and you can forward 100 streams and get the real-time responses, which is
I'm
really cool.
curious. Have you tested this on any of those virtual GPU machines, such as the Amazon G5s, that kind, or the G3s, that kind of stuff?
Yeah, honestly, we didn't test. It's a very new technology which appeared just
Hmm.
this month, but yeah,
Oh,
it would be really interesting to test. Just,
I might actually try it myself. We have
yeah,
instances for that. So
yeah, if someone could try and just tell me the numbers, or I'm ready to help on. Just
cool.
we can
Yeah,
just
that's super interesting. Yeah, those machines can be expensive for sure, but they're not that expensive, to be fair. It started under what, under 20, under 40 a month, which is, I mean, if you're running this kind of traffic, it's not too expensive. So it's yeah, I will look into. Well, first of all, I need to start running the switch. I'll let you
Mhm.
finish, but then the first question I have is, how does someone get started easily?
Um, yeah, well, let me check if I have. Yeah, so that's all I wanted to share, actually. Yeah, those
Mhm.
are almost all the items. To get started, yeah, you can run this Docker command. That's it.
And then what's the client to connect to that? Like, how
The
do?
client is, we have the free switch plugin. I don't think I shared it, but I
Mhm.
can. Let me share the browser window. Uh, one second.
Yeah, it's better to stop the.
Yeah, I just shared the. Uh, so here it is. We have this.
Oh, super easy.
Yeah, we have we have the free switch fork, but essentially it's a plugin. You compile it, and you can add it to the dial plan, and you start the server, and you can use the standard free switch speech commands to cooperate with it. You forward the uh, speech in the dial plan, and you get the response in the text speech results. Or you can use Lua or whatever scripting language you want to add.
Nice. What about getting started from WebSocket audio? So, say I have a way to send audio over WebSocket to something. Is there support for that, or do you need a wrapper around it? Just curious because we have a prototype like that.
Yeah. So essentially, the server it handles WebSocket connection. There is
Oh,
a simple protocol that you can send the configuration there. You can send the end of speech message there. So essentially, but then you just send the raw data over WebSocket. You might need some bits on the WebSocket messages, but otherwise you just handle the audio and send it to the server.
I have to ask, how's the Italian model like? Is it?
Uh, yeah, Italian model is small.
Hmm?
I think it's more like for the mobile applications, but we might have the big model for the telephony as well. There's no problem. Actually, Italian is one of our kind of interesting languages to work on. Uh, yeah,
For
so
sure. Cool. Yeah, that's there. I mean, there's so much that's interesting here that I can't wait to play with it. Great. So, yeah, I'm super happy what we went through today. It's been a while since I was really looking forward to this episode. I'm looking forward to all episodes, but speech recognition is something I never got working quite right on the open source models. So I'm going to sit down and try. I have to finish a prototype this afternoon, and my next thing is going to be trying to run something over WebSocket and see what happens. So I'm not a native speaker, so I hope my English is good enough. But the if the quality is good, this shouldn't be a problem. And well, Nickolay, what else? Thank you so much for joining us today. It was super interesting. It's really something the
absolutely.
open source community is not really leveraging enough because there's so much we could do with speech recog that if we all worked on it a little bit more, we could make it better faster. I think even just contributing language models. I guess is it hard to contribute a language model out of curiosity? Like, say I'd like to contribute the Italian one.
Um, Yeah, that's a different, process. These days, you do not need to contribute anything.
Oh,
Uh,
wow! I didn't
the
know.
because the technology comes to a point where the more and more languages are supported already,
Hmm?
and more data is available. And big corporations like Facebook, they're releasing kind of multilingual models to handle, all the speech languages in the world, which can adapt to just with the 10 minutes of speech you can get pretty decent speech recognition. And I
Wow, that's
believe
awesome.
the biggest issue these days is not about the languages, but more about kind of computing and engineering infrastructure around this. Because you see, you can have the speech recognition, but that's not just the only thing you need
Oh
to
no,
care
true.
about. You need to create the output, and you need to understand what client is saying. You need to get some information from this. You need to quickly turn it into the speech with the TTS, and you need to quickly feed it back. And the critical thing here is quickly. To be useful, you need to do all those things in less than a second, ideally less than a half of a second. And there are just technical problems here. How do you arrange the software components? How do they cooperate? which algorithms they use. For example, the many TTS packages available today, they're quick, but
Mm,
still to create the single response of 10 seconds, they need like 1 or 2 seconds still. And
mm.
you see, when you want to create the response, you need to do it immediately. And
Yeah. Yeah, I think you're totally right. It's what I my one of my favorite definitions in telephony is it's always easy to make one phone call. Like if you get started
right,
with whatever you're doing, install for a switch, your first phone call takes 15 minutes.
right,
Then
right,
to make a
right.
million phone calls takes 5 years.
Exactly, exactly. Yeah, so I see there are a lot of engineering problems. Like streaming TTS is a big problem these days. It's not available, I
Mm,
believe, in public, but that's something that telephony guys would really need because they really need to get the answer fast.
yeah, you're
Otherwise,
right.
it's just a toy. It's just a toy. You say something and then you wait for 3 4 seconds to get the information.
Yeah,
Um,
before we wrap up, I do have a question that's unrelated, but I'm just curious. What is the status of open source text to speech these days? If you have any information, like because that's another engine, another side that's not very well known.
No, there are many interesting projects here. Like there is a spin-off from Mozilla, a team called Koki.
Hmm.
They're doing speech recognition and they're doing really great TTS these days. It's not probably perfect, but it's really a reasonable thing to do. And then there is Nvidia, who is putting a lot of effort in this AI technology, and they also have several TTS packages which one can try, and they create really natural really natural speech from the text input, but it's all about integration.
Very, very nice. Yeah, it looks like Nvidia actually has an interesting, cool. So yeah, I think I'm gonna have to go and play with some of this with Vosk first
Yeah,
because
exactly.
tech.
Well, the TTS you can also do many interesting things because you can these days you can clone voices. You can clone your voice with just 5 minutes of speech. You can implement different accents, different styles, different voices just with a single parameter adjustment. So a lot of things to play here, and also lately, it's a very kind of interesting technology from NVIDIA too that you can synthesize the face,
Oh
not
wow.
just the TTS, but you can also have this face speaking, which is something
Well,
next
to
generation.
be honest, if you want, I hope I don't spoil anything for anyone because I mean it's been out for a while. But there's been a recent Star Wars uh, TV series where one of the characters is actually not there at all. Like it's not even him. And I
Right,
told
right.
because it's a younger version of an actor who now is 70 and something, but I thought the voice was his. In reality, not even the
Mhm.
voice is his. Like nothing. There's nothing there. It's another actor providing the body, and then the face and the voice are just completely generated. So you could do a movie with anyone at this point.
Exactly. But this technology, the interesting thing that this technology comes to real users, it comes to telecom, and that's what exciting. So
Yeah,
it's not
very
just
much.
about Star Wars.
Well, still,
Mm,
it's funny to see how they can make a movie with someone that's not really there, technically doesn't exist, because that's a younger version of an existing person, but technically that person doesn't exist anymore, right? So
mhm.
it's you could do anything you want. It's super interesting and scary at times, but let's not go there. Like you can make anything.
Exactly, exactly.
Cool. Well, Nikolai, thank you so much for joining us today. Again, it was super interesting to me, and it's been a great journey through open source speech recog. I urge anyone to try go out, check out Vosk, try it out. Looks simple to start. It's relative. I mean, I shouldn't have a problem either. And I'll be playing with it next few days. And thank you again. It was just
Thank
great.
you. Thank you. Yeah.
And
If
I
you
hope
have
I
any
see you at
questions,
ClueCon.
yeah. Thank you.
I hope I see you at ClueCon soon. And for the rest of the people, see you next time.